Welcome back. We are working our way through our exercise number 7 here. Let's just pull it up. We are looking at proving that n times 2 to the n is in little o of 4 to the n. And we're going to do this using some of our properties. So right away, we can see that we do have to sort of split this in half again so that we can use these two different terms and then work our way into solving this problem. So I will sort of just show very quickly that if I move down here, we do something like this at the very bottom, because this is what we know we're trying to prove. If we want, we can go into here and in the, where is it? In the multiplication, here we go. We have proofs such as this one right here. We have a property such as this one, right? And when we have this property, what that tells us is that if we can prove n is in O of little o of 2 to the n, and we can show that 2 to the n is in little o of 2 to the n, then by 5.4, we can say n times 2 to the n is going to be an O of 4 to the n. Okay, so the reason why I'm showing this is because it's important for us to understand that if we're not really sure where to go next in our proof, when we start one of these problems, we can always start at the end. I'm just going to move it down even more because we can look at this right here and see that we have two terms, right? Term 1 and term 2, and go, okay, well, we know that those had to be combined somehow. And so then we can start by looking at the very last step, recognizing that this needs to somehow make its way into some factor of this, and this needs to make its way into some other factor of this, such that these multiplied together will give us that 4 to the n. So we can definitely start looking at our proof in that direction if we're not really sure how else to start. It's almost like a maze where you start at the top and you start at the bottom, and you sort of need to weave your way until you end up with the two parts together. So as we've, oh, that was weird. As we've seen, we're going to use our property 1.4 to start us off with, there we go, with trying to prove that n is going to be in some factor of this. So as we just said, we know we need to find a way to get n into some factor of that. I know that it needs to be in 2 to the n because 2 to the n times 2 to the n is going to work beautifully. Plus, we already had this 2 to the n, so that was helpful also to sort of see. But anyway, so we're going to do exactly that. We're going to take this property and we're going to notice that n to the 1, n to the a can be like n to the 1. And we can see that we're going to actually put this in 2 to the n, we decided, right? But we can see that 2, that b is equal to 2, which is greater than 1. Therefore, it follows that n is going to be in little o of 2 to the n. And that's just thankfully all we have to do for that first step there. That's it. When we want to go and look at the second step here, so now we've proven this side. When we want to go and look at trying to figure out how we're going to do this side of things, 2 to the n is in little o 2 to the n. Well, we're going to start by looking at a different property. Let's start by looking at this property right here. This property 2.1. So if we look at the property 2.1, it says that if f is in big O of g and g is in big O of h, then f is going to be in big O of h. Now, this is going to be mighty obvious, I guess, but if 2 to the n is going to be in big O of 2 to the n, which we know is the case because just numbers, and when we do 2 to the n is in big O of 2 to the n, then big 2 to the n will indeed be in big O of 2 to the n, right? So clearly by using 2.1, we can see that that 2 to the n is in theta of 2 to the n, right? There's nothing else to it, so that makes sense. And so we have 2 to the n in that big O of 2 to the n. So yeah, that is a little bit redundant, obviously, right? It's obvious, but it's still nice that we're able to state it by saying if we use property 2.1, we can find ourselves in theta of 2 to the n, which then means obviously if 2 to the n is in theta of 2 to the n, it's definitely going to be in big O of 2 to the n. So then using those two pieces of information that we've now shoved together, we're able to say in step 3, by 1 and 2 and property 5.4, we can take each of those pieces of information, take our property and put it all together like so. So this one does sort of use the property 2.1 in kind of a weird way. In fact, it's not even really necessary for this proof, right? The fact that 2 to the n is in big O of 2 to the n is trivial, it's redundant. However, when you look at our notes, it is something that we sort of call out directly. So I thought I would copy that sort of style to ensure flow with the notes, let's say. But yeah, so step 2 here, it is just trivial to say that 2 to the n is obviously going to be in theta of 2 to the n. There's no other terms on it. And if it's in theta of 2 to the n, it's going to be in big O of 2 to the n. So that's not really necessary to say, but it is nice to sort of state it in its own like number, because now it's easy for us to just say by 1 and 2 and the property, here we go. But you would be right to question why we would even need step 2, because it isn't really strictly necessary. Okay, well, we are almost through all of these. I think we've got about 3 left. So thank you for joining me in this video, and I'm looking forward to seeing you in the next one. Thanks, y'all, and have a great day.